Hey everybody, let's talk about how to write ionic formulas. So let's say they give us a name of a chemical compound that's held together by ionic bonds. So how do we know it's held together by ionic bonds? Well, we look at what side of the table they're from. So remember, everybody over here are the metals. In fact, on your table, let me sort of darken it right here, you'll see a little staircase. So what's the staircase about? Well, the staircase is separating the metals from the nonmetals. So whenever you have a metal from this side of the table joined together with a nonmetal from this side of the table, you have an ionic compound. These guys get positive charges because they lose electrons. These guys are negative because they gain electrons. So these are positive ions, we call them cations. These are negative ions, we call them anions. So let's talk about how we're going to write some ionic formulas. How would we know they have to go together? So let's look at an example here of a simple one. So let's start with sodium chloride. That is typical table salt. So we got to find sodium on our table and see what its charge is. So here is sodium. It's in the first column, and it's right here. It gets a charge of +1. And then chloride, you may look on the table and not find chloride anywhere. When we have an ionic compound, we call the second element, we end it with "ide." And so chloride is chlorine when it's in an ionic compound. So chlorine's in group 17, which means it gets a charge of -1. And it's right there on the table. So let's write this down here. So we will have our metal over here, sodium. And sodium gets a charge of +1. And then over on the other side here, we'll have our nonmetal, chlorine. Chlorine gets a charge of -1. Well, they're trying to get balance. They want it so that there's no excess charge. And these guys, they're already balanced out like that. So when they come together, they're already happy. So that sodium, because it's positive, will pull in that chlorine because it's negative, and you get sodium chloride there. By the way, we don't write ones if there's only one of them. There's this temptation to write a 1 here and a 1 here, but we don't do that if there's just one. So there is the chemical formula for sodium chloride. Let's try another one. Let's do lithium oxide here. So lithium oxide. So first thing, let's find our metal, lithium. If we look in the periodic table, it's right here in the first column, so it gets a charge of +1. So lithium, Li, plus. And again, just like with the other numbers, sometimes you'll see them not write anything. You'll see some teachers, I like to go ahead and write it, but you might just see a plus written there. So +1 for lithium, and then oxide. Again, what's oxide? That's just oxygen when it's in an ionic compound. So oxygen's here, we can see it gets a charge of -2. So these guys do not balance. We've got more negative charge than we do positive charge. So how are we going to balance that out? Well, 2 lithiums ought to do it, right? So if I have 2 lithiums together, that's a total charge of +2, and that will balance out the oxygen, which is -2. So we write it like this. Li2 to indicate we need 2 lithium atoms and just 1 oxygen atom, and so we don't write anything there. So 2 lithium atoms will balance out 1 oxygen atom there. Let's do another one here. So let's do something called potassium nitride. So for potassium nitride, maybe you want to pause the video and give this one a shot yourself first. And see if you can do it. So potassium, that's K. It's got a charge of 1. I see that there. And then nitride is what we call nitrogen when it's in a ionic compound. So potassium is +1. Nitrogen is -3. So let me write down my charges here. Potassium is +1. And nitrogen here is -3. And just like before, we can see that there's an imbalance here. So we are going to need, in this case, 3 potassiums to balance out that 1 nitrogen. So that will give us a total charge of +3 on this side and -3 on that side. So we write K 3, and then N, and remember, don't write the 1, we write K3N, and that is potassium nitride. All right, maybe you're getting the hang of it. So let me give you a slightly more difficult one. This is the first type of one that throws some people off. Aluminum oxide. So aluminum, let's find it. It's got a charge of +3. It says it right there on it. Oxide, remember, is oxygen. It's got a charge of -2. So let's write this down. Our metal has a charge of +3, and our non-metal has a charge of -2. Oh man, how's this going to work? We got more positive charge than negative charge. So I'll add some here. But now I got more negative charge than positive charge. So I've got -4 here and +3 here. So let's add another aluminum. Uh-oh. Now I got more on this side again. I've got +6 on this side and -4 on this side. But here we go. Now we can see. Now we have made it a little bit, or we have made it balanced here. So 2 aluminums will give us +3. 3 oxygens, excuse me, 2 aluminums will give us +6. 3 oxygens will give us -6. So this formula is aluminum 2 and then oxygen 3. And so aluminum oxide there. One way you can actually think about it, a hint on all of these ones that we've done is, now this doesn't always work. I'll show you some cases where you got to be careful on this. But let me go back and do the ones that we've already put up here. So we have started with sodium chloride. And you can actually sort of cross it over. Like move the chlorine charge down here, 1 sodium atom, and move the sodium atom down here, 1 chlorine atom. That will work. Let's look at lithium oxide. So lithium had a charge of +1, so we can move that number down here. Oxygen has a charge of -2, but we can move that to the number down there. That's sort of a hint to tell you how these are going to form. Here's potassium nitride. So move the charge to the number of nitrogen. So 1 becomes down here, and 3 comes down here. Now that won't always work. I'll show you a case in which it won't work, but it works here again. Move the 3 down to the number of oxygens and the 2 down to the number of aluminums. So let's just do a couple more real quick here. Hopefully we've got the hang of it. On these, I can't at home force you to do this, but why don't you try and see if you can do magnesium chloride on your own. So pause it, try it. So here's magnesium. It's got a charge of +2. And here's chlorine. It's got a charge of -1. So we write it like this. Magnesium has a charge of +2. Chlorine has a charge of -1. And I can see I'm going to need 2 chlorines to balance that 1 magnesium. So we write MgCl2. And you obviously don't have to write them in different colors. I just do that to make it a bit obvious what the 2 different elements are. So there's magnesium chloride. Again, could move the Mg down here and the chlorine charge down there. Let's do calcium oxide or calcium fluoride. And then actually I want to show you an example of calcium oxide. So here's calcium fluoride. So let's find calcium. Calcium is a charge of 2. And fluoride is fluorine. It's a charge of -1. So calcium is our metal. So +2 is its charge. And fluorine is our nonmetal, a charge of -1. I can see I'm going to need 2 fluorines to balance that 1 calcium. So CaF2. And so that will be a balanced calcium fluoride atom. All right, let's do strontium phosphide here. So strontium is all the way down here. It's Sr. It's got a charge of 2. So our metal's got a charge of 2, +2. And then phosphide. Phosphide's the word for phosphorus when it's in an ionic compound. So here's phosphorus. It's got a charge of -3. Oh, and we've got one of these kind of like aluminum oxide again. I got to try and balance them. So strontium here will be +4. And I can see that I got to do one of these where I got to get it up to actually a total charge of 6 here. So 2 phosphoruses will give us a charge of -6, and 3 strontiums will give us a charge of +6. So strontium 3, and then 2 phosphides. So this would be strontium phosphide. Again, a shortcut could be you could just actually move this charge down here for the number of phosphide and the other way. But let me show you one case in which that doesn't work, and a way that you can still use that, but you just got to modify it a bit. So let's do one here that is, let's say, calcium oxide. So calcium oxide, let's look up our charge of calcium. It's +2, and oxygen is -2. So when we go to do that, let's write that. Calcium is +2, and oxygen is -2. So you can see they're already balanced. They're already happy. So they will actually just look like this for their chemical formula, CaO. So this is one case where that crossing down doesn't work. But if you want to think of it as a fraction, then you can just reduce, like 2/2 and reduce it down to 1. So that is examples of writing ionic compounds.